Okay, I put off making this video because I had laryngitis and I think my voice is pretty much back to normal. So we're going to talk about metallic bonding and polyatomic ions. And I've gone over this in class a little bit, but I wanted to make this video just in case some people didn't understand and need to go back over it, or if you missed class. Well, let's talk first about polyatomic ions. Now the prefix poly means multiple or many. And then atomic refers to atoms. So polyatomic ions are many atoms that come together that form an ion. And that's an ion, member, has a positive or negative charge. So with your chemistry reference materials, you have on one of those sheets a column that says polyatomic ions at the top, and it looks like what we have here on the left hand side. And I've also given you a sheet, polyatomic ion sheet, that you can glue in your notebooks that we're going to be starting to keep for the spring semester. So here the polyatomic ions are listed with their name. And let's look at the 5th one down, chlorite. We can see that the formula for chlorite ion is ClO2 with a -1 charge. Now, the thing about polyatomic ions is they form bonds with monatomic ions. Monatomic, mono meaning one atom ions, just like we've looked at binary compounds. So if we take the chloride ion and we bond it with magnesium, magnesium has an oxidation number here we see of 2, and the chloride ion has a -1. So if we're going to write a proper formula, remember we take these oxidation numbers and we crisscross. That 2 goes there and this 1 will go here. So this tells us we need 1 atom of magnesium to bond with 2 atoms of the chloride ion. So the proper formula is going to be MgClO2, and we need 2 of those. And since we need multiple polyatomic ions, we have to put it in parentheses. And one way you can remember that is because if it didn't have a parentheses here, it would look like ClO22. And that's not what we want. We want ClO2, 2 of these units. So think about this polyatomic ion as a unit that you cannot break up. Okay, so this would be called magnesium for the name, magnesium, and we don't change the name of the polyatomic ion. So on binary compounds, remember the ending is what? IDE. Okay, but on polyatomic ions, we do not change the ending of the polyatomic ion. We keep the name, so it's magnesium chlorite. Now there is one polyatomic ion that has a positive charge, so it's a cation, and that would be ammonium, and it has a +1 charge. We do the same thing with ammonium. So if we're going to bond ammonium with sulfur, ammonium has a +1 charge, sulfur has a -2 charge, so that means we need 2 ammonium ions to bond with 1 sulfur ion when we do the crisscross method. And again, we don't want this to look like NH42, so we have to put parentheses around the polyatomic ion to write the 2. Okay, so the name of this is going to be ammonium sulfide. Now this is a single atom. It is the second element in the compound, so we do change the ending to IDE. But we don't try to say nitrogen hydride sulfide. That's not correct. This is an ammonium ion, so we're going to keep the name ammonium, so it's ammonium sulfide. Now, 2 polyatomic ions can bond to each other. Okay, so we have ammonium here with the +1, and again we're going to use our example of chlorite with a -1. So when we try to get the correct formula, we're going to crisscross these. So we need 1 chlorite to bond with 1 ammonium. Now since we only need 1, we don't have to put parentheses around anything. So the correct formula is NH4ClO2. The correct name would be ammonium chlorite. Okay, now moving on to metallic bonding. When atoms of a metal bond together, they form what's called a sea of electrons. And you can see here. Now the thing about metal atoms is they have all these electrons that are hanging out in their either outer shell or very close to the outer shell. We're talking about the transition metals, the metals that are in the D block. And those electrons do special things, and so they hang out very close to the outer shell. They're not actually on the outer shell, but they're very close to the outer shell. So when atoms of metals bond together, you have all these electrons that are in between them, that just hang out in between them. And they're not really bonded to any particular atom. They're free to move about in the solid. So we see a pictorial diagram of it right here. And because you have all these electrons that are hanging out between these atoms of a metal, that gives them special properties that we need to know about. Okay, and one of those characteristics is malleability. Okay, and malleability is the ability of a metal to be hammered flat. So if you take a mallet or a hammer and you beat this metal, okay, then you can hammer it flat out to a thin sheet. Metals are very soft. If you've ever gone fishing, then you use lead weights to weight down your line some of the time. And if you use the little teardrop weight that has the little metal that goes through it, you can actually take your thumbnail or fingernail and scratch into that metal. It's very, very soft. You can also, if you use the oval weights that have the little tabs at the end to put directly on the line, then you know you put the line in a little groove that's in the weight, and then you can actually, with your fingers, bend over the tabs to attach the weight. So metals are very, very soft because of all of the electrons that are in between the atoms. So it gives them this property of malleability. The next property that they have is ductility, and ductility is the ability of a metal to be stretched into a thin wire. And the last characteristic that we're going to talk about is that because they have all these electrons that are not really bonded or attached to any particular atom, then they're free to move around between the atoms of metal, and these electrons, when they start actually moving, or when an electron starts moving, then that's conducting electricity. These electrons are free to move about. When electrons move down a metal wire, that is electricity, and metals are very good at conducting electricity. That's why we use in our homes copper wire in the home to go from the outside telephone pole to your home, and they also are inside your home. When you flip your light switch, those electrons go down the metal, the wire, copper wiring, to the light. That's what makes the light come on.